How does a company that built 15,000 P-47 Thunderbolts, shaped Cold War air power with iconic jet fighters, and gave the military the A-10 Warthog simply cease to exist? Republic Aviation didn't disappear because it ran out of ideas. It disappeared while still producing some of the most consequential combat aircraft in American history. From a Russian immigrant's first amphibian to the Fairchild merger that finally erased the Republic name, the answer begins with a small, all-metal seaplane in 1933. In June 1933, Russian-born aviator Alexander de Seversky took the controls of his company's first creation, the SEV-3, lifting off from Long Island waters. At a time when wood and fabric biplanes still dominated the skies, this single-engine, three-seat amphibian was a radical statement of intent. It featured an all-metal, low-wing monocoque structure and innovative split flaps, designed not just for utility and training, but to prove a young manufacturer's technical capability. While only 6 of the original amphibian models were built, the overall line exceeded 36 airframes once the design was adapted into landplane trainers for the military. More than a versatile utility craft, the SEV-3 served as the engineering testbed that established Seversky's industry credibility. The structural strength and aerodynamic lessons refined on this seaplane directly paved the way for the company's transition to combat aviation, shaping the rugged monoplane fighters that would soon follow. In 1935, the company shifted from experimental utility craft to dedicated combat aviation with the P-35. Designed as a single-engine, single-seat propeller fighter, the P-35 was the United States Army Air Corps' first modern all-metal monoplane fighter, featuring retractable landing gear and an enclosed cockpit. Up to 196 of these aircraft were built for the military and foreign customers, establishing a structural foundation for pre-war American air power. The fighter was built to intercept incoming bombers, proving that all-metal monoplanes were the future of military aviation. The design mind behind this era was Chief Engineer Alexander Kartveli, who championed heavy armament, structural strength, and high-power radial engines. Kartveli used the P-35 platform to explore different military roles in international markets, shaping the company's engineering identity and setting the stage for more powerful designs. To test these export possibilities, the company developed the A8V in 1935. Produced as a single-engine, single-seat propeller fighter, 70 of these aircraft were built. This limited production branch allowed the design team to experiment with variants and foreign sales while maintaining the core metal construction of the original fighter. By 1939, the search for higher speeds and better high-altitude performance led to the XP-41. Only a single prototype of this single-engine, single-seat propeller fighter was built. The XP-41 acted as a one-off development step, testing early turbo supercharger integration directly on the airframe to increase power at extreme altitudes. This single airframe kept Kartveli's team moving forward, proving the technical concepts that would soon push the manufacturer into serious military contention as the world edged closer to war. In 1940, the search for high-altitude power became a reality with the P-43 Lancer. Republic built 272 of these single-engine, single-seat propeller fighters to serve as an intermediate step for the Army Air Corps. While the Lancer successfully integrated a turbo-supercharged radial engine, rapid combat developments in Europe soon proved the design was underpowered for the escalating conflict. Looking to leap ahead, Alexander Kartveli envisioned the P-44 rocket, a planned single-engine propeller fighter designed to carry a far larger power plant. However, This ambitious fighter never reached production. Engine shortages and changing military requirements canceled the program with 0 units built. This sudden halt showed how quickly tactical doctrine was moving, outstripping hardware before the factories could even cut the first sheet of metal. The setback forced Republic to abandon incremental upgrades and focus entirely on a massive, heavily armed machine built for a brutal new era of air combat. In May 1941, the prototype XP-41B rolled out of the Farmingdale Assembly Hall. It was the largest, heaviest single-engine fighter ever built. Instead of shaping a fuselage and squeezing an engine inside, Chief Engineer Alexander Kartveli did the opposite. He started with the Pratt & Whitney R2800 double WASP radial engine and a massive turbo supercharger unit. Kartveli placed the supercharger in the rear of the fuselage, then ran long metal air ducts along the bottom of the plane to connect it to the engine up front. The entire fuselage was essentially built around this cavernous air system, giving the aircraft its characteristic wide, barrel-like shape and earning it the enduring nickname, the Jug. While European designers focused on lightweight agility, Kartveli built for brute strength, high-altitude performance, and survival. The United States Army Air Corps initially wanted a light interceptor, and senior officers like General H. Arnold questioned the aircraft's immense weight. But combat realities in Europe soon validated Kartveli's design. To survive high-altitude air battles, a fighter needed immense power, heavy protection, and devastating firepower. The Thunderbolt delivered all three. It carried 850 caliber machine guns mounted in the wings, backed by a structure wrapped in steel armor plate and self-sealing fuel tanks. Its landing gear used telescoping struts that shrank during retraction, allowing the massive frame to remain aerodynamically clean in flight. In the skies over Europe, the Thunderbolt proved its worth. It could dive at speeds that would tear lighter fighters apart, utilizing its weight to escape danger or run down targets. Its Pratt & Whitney engine, supercharged to maintain power at 40,000 feet, allowed pilots to escort heavy bombers deep into enemy territory. When hit by anti-aircraft fire or enemy shells, the rugged airframe absorbed damage that would have destroyed other aircraft. Pilots returned to base with entire cylinder heads shot away, massive holes in the wings, and shattered tail surfaces. This legendary durability gave pilots the confidence to press their attacks, knowing the heavy metal structure of the Jug would bring them home. As the war progressed and lighter fighters took over escort duties, the Thunderbolt transitioned to ground attack. Its massive payload capacity, eventually reaching 2,500 pounds of bombs and rockets, turned it into a devastating tactical weapon. The rugged, air-cooled radial engine, lacking the vulnerable liquid cooling systems of other fighters, made the aircraft exceptionally resilient against ground fire during low-altitude strafing runs. To meet the insatiable demand of the global conflict, Republic grew from a struggling pre-war manufacturer into an industrial colossus. The company scaled up operations across two main assembly facilities: the original plant in Farmingdale, New York, which produced 9,394 aircraft, and a massive new facility in Evansville, Indiana, which added another 6,242 to the wartime effort. Between 1941 and 1945, these factories turned out 15,636 Thunderbolts. At the height of wartime production, the Farmingdale plant operated 24 hours a day, rolling out 28 completed fighters every single day, one aircraft every 30 minutes. Building each plane required 22,927 man-hours and a sprawling network of over 100 subcontractors across the nation. This immense manufacturing effort cemented Republic's position as a titan of the American defense industry, proving that a heavy, rugged machine could dominate the skies through sheer engineering force and unmatched industrial scale. Even before the war ended, Republic's engineers were pushing the limits of piston technology. They designed the XP-69 as a single-engine, single-seat propeller fighter, though it remained entirely on paper with 0 units built. In 1944, the company built 2 prototypes of the XP-72, a single-engine, single-seat propeller fighter designed to preserve high-end piston performance and push the late warfighter concept to its absolute limit. Both projects represented a peak of reciprocating power, but the swift arrival of the jet age soon made them obsolete. With military contracts evaporating in 1945, Republic pivoted to the civilian market with the RC-3 Seabee, building 1,060 of these single-engine, 4-seat pusher-propeller amphibious aircraft. It was a major gamble designed to capture a predicted post-war boom in personal aviation. But high production costs and a shrinking market turned the venture into a financial disaster, draining the personal savings of company executives. By 1946, Republic tried to broaden into long-range reconnaissance transport work with the XF-12 Rainbow. Only 2 of these 4-engine aircraft were built. Though engineered for high-speed and long-range missions, the Rainbow was sidelined by post-war budget cuts and the emergence of jet competition. These transitional designs ended Republic's piston engine era, forcing the company into an uneasy phase of reinvention. In 1946, Republic secured its position in the emerging Cold War with the F-84 Thunderjet. Built as a single-engine, single-seat fighter bomber, the straight-wing design was the company's first operational jet. Republic manufactured 4,285 Thunderjets, demonstrating that its factories could mass-produce jet technology at scale. The aircraft became a workhorse in the Korean War, establishing Republic as a major supplier for the United States Air Force and NATO. To solve the limitations of early jet power at high altitudes, Republic developed the XF-91 Thunderceptor in 1949. Engineers built 2 of these single-seat, mixed-propulsion interceptors, combining a turbojet with auxiliary rocket engines for rapid climbs. The prototype featured a radical inverse taper wing, wider at the tips than the root, designed to prevent low-speed stalls. While the rocket systems proved too complex for active service, the aircraft provided valuable supersonic flight data. By 1950, the demand for higher speeds led to the F-84F Thunderstreak. Republic modified the straight-wing design by sweeping the wings and tail back at a 45-degree angle. This refinement produced a faster, more agile fighter, resulting in a production run of 2,711 aircraft. This family of aircraft expanded further in 1952 with the RF-84F Thunderflash. To adapt the swept-wing platform for dedicated reconnaissance, engineers moved the engine air intake from the nose to the wing roots. This modification freed the nose to hold a camera suite capable of mapping enemy lines. Republic built 715 Thunderflashes, turning tactical reconnaissance into a primary mission. Together, these designs kept Republic's assembly lines running and proved the company could adapt to the rapid technological demands of the jet age. As the Cold War accelerated, Republic moved past conventional flight, chasing radical designs that tested the physical limits of aviation. In the early 1950s, engineers proposed the XF-103, a Mach 3 interceptor built to combine a turbojet with a ramjet. To withstand extreme friction, the aircraft required an all-titanium structure and a periscope instead of a traditional windshield. With 0 units built, it remained on paper, doomed by technical hurdles and soaring budgets. In 1955, the company built 2 prototypes of the XF-84H, a single-engine, single-seat turboprop fighter designed to test supersonic propeller blades. Dubbed the Thunderscreech, the aircraft generated a continuous, bone-rattling sonic boom from its high-speed propeller tips. The deafening noise physically incapacitated ground crews, causing severe headaches and nausea, which quickly forced the military to cancel the program. By 1957, Republic took the imagination further with the AP-100, an unbuilt 6-engine VTOL strike fighter designed for nuclear attack. Like the Interceptor before it, the AP-100 saw 0 units built. These projects exposed the high price of chasing the edge of technology, proving that extreme concepts often clashed with military reality. In October 1955, Republic flew the prototype of its final large-scale combat design, a machine that eventually saw 833 airframes built. This was the F-105 Thunderchief, a massive single-engine, single-seat jet fighter bomber. It was not built for the agile aerial dogfights of the Korean War, but for a singular, brutal Cold War mission: high speed, low-altitude penetration to deliver a tactical nuclear weapon far inside enemy territory. Alexander Kartvel's team shaped the heavy aircraft around a spacious internal bomb bay, and distinctive swept-forward wing root air intakes, allowing the jet to reach double the speed of sound. When conventional warfare demands overtook nuclear planning, the F-105 adapted to carry up to 14,000 pounds of conventional bombs, exceeding the payload of a World War II heavy bomber. But this specialized focus came at a high price. To sustain its massive Long Island facilities, the company now relied almost entirely on single-program military funding. There were no civilian safety nets or diverse product lines to cushion the blow if Pentagon priorities shifted. The F-105 kept the assembly lines running at peak capacity, but it also bound Republic's financial survival directly to the volatile defense budget, leaving the manufacturer vulnerable to the corporate changes that lay ahead. In 1965, the Fairchild-Hiller Corporation acquired Republic Aviation for $24.5 million, establishing Fairchild Republic. This corporate consolidation was the direct result of shrinking defense contracts and soaring research and development costs, which stripped Republic of its independence. Though the merger altered the corporate structure and caused significant boardroom turnover, the engineering spirit of Farmingdale survived the absorption. In 1972, this combined team produced the A-10 Thunderbolt II, a twin-engine, single-seat jet ground attack aircraft. Republic built 716 of these machines to destroy enemy armor at low altitudes. The aircraft's mission made it a direct descendant of the company's wartime designs, built with the same rugged combat thinking, wrapped in a titanium armor bathtub that protected the pilot and carrying a 30mm rotary cannon. The A-10 resurrected the heavy firepower and legendary survivability of the original P-47. The aircraft became a late-career signature for the combined company, preserving Republic's design DNA even as its original identity faded. When production ended in 1988, the parent company sold the program and closed the Farmingdale facilities, ending the institution itself. What does Republic's rise and fall tell us about how industrial design, wartime demand, and corporate strategy shape the aircraft we fly and the wars we fight? Today, Republic's name is gone, but its philosophy of rugged survivability still protects pilots in modern skies, A brand can vanish from corporate ledgers, but true innovation is never erased. As we look at the giants of aerospace today, we must ask, did Republic truly disappear, or did its DNA simply dissolve into the very future of flight? Share your thoughts in the comments.